Learning outcomes. After studying this module, you shall be able to learn and understand the concept of elasticity of demand and price elasticity of demand, factors that affect price elasticity of demand, methods to compute elasticity, relationship between total revenue, marginal revenue and price elasticity, income elasticity of demand and cross price elasticity of demand. Introduction. When a producer decides to fix or revise the price of a good, he finds it difficult to decide whether to lower or raise the price. For example, when the owner of an amusement park decides to raise the ticket prices, the price hike would lead to lower attendance at the amusement park. However, the price rise led to an increase in the owner's revenue, that is, the ticket price multiplied by number of tickets sold, because the higher ticket price more than offsets the smaller number of tickets purchased. But this is not always the case. Rise in price may not always lead to an increase in sales revenue. For example, when a beverage company A increases the price of a certain cold drink, rival producers may leave their prices unchanged. In this case, A would experience falling revenue, as consumers would shift to the other brands of the cold drinks. The lower quantity of cold drinks sold would more than offset the higher price and hence lead to a reduction in revenue. In general, when producers change the price of a product, total sales revenue may rise or fall depending upon the responsiveness of the consumer and other producers to the price change. Firms recognize that price and demand are inversely related, but it is also very important to assess by what percentage quantity demanded will change when the price changes by a certain percentage. This information is not directly given by the law of demand. There can be a substantial difference in the way total sales revenue of a firm is affected due to change in price. A 10% decrease in price can lead to a 3% rise in quantity demanded for good S, whereas a 10% decrease in price of good T can cause a 50% increase in quantity demanded. Moreover, quantity demanded also responds to the changes in the consumer's income. The degree of response depends on the nature of the good and is measured by the income elasticity of demand. Also, there is a concept cross price elasticity of demand which captures the response of quantity demanded to the changes in prices of the related goods, which may be complements or substitutes. All these concepts would be discussed in this chapter. The demand function for good X is given by Qx, which is a function of price of good X, price of Y, income, taste, etc. Price elasticity measures the percentage change in quantity of good X when there is a percentage change in price of X. Similarly, cross price elasticity measures the percentage change in quantity of X for a certain percentage change in the price of the related goods Py. Income elasticity measures the percentage change in Qx for a certain percentage change in income M. Elasticity of demand refers to a proportionate change in quantity demanded of a good to a proportionate change in any of the other determinants of demand, be it own price, income or price of a related good. This unit is devoted to the concepts of price elasticity of demand as well as other elasticities. First, we introduce the basic concept of price elasticity of demand, which is followed by the relation between elasticity and revenue received by the firm from the sale of the product. Factors determining the intensity of the response of consumers concept of marginal revenue, its relation with demand, income elasticity of demand and cross price elasticity of demand. Price elasticity of demand. Basic concept. Economists use price elasticity of demand, denoted by epsilon, to measure the responsiveness of demand for a commodity to a change in its price. From the law of demand, we know that as price increases, the quantity demanded of a consumer will decrease. The proportionate change in quantity demanded in response to a proportionate change in price is referred to as the price elasticity of demand. In percentage terms, the price elasticity of demand measures the percentage change in quantity demanded of a good due to a 1% change in its price. The formula for price elasticity can be written as percentage change in quantity demanded divided by the percentage change in price, which may also be written as dQ by Q divided by dP by P. Note that the law of demand implies that dQ by dP is negative, while P and Q are positive. So, with negatively sloping demand curves, elasticity would be a negative number. In some contexts, it is common to introduce a minus sign in the formula to make this a positive number. From the formula above, you can observe that price elasticity of demand depends on the inverse of the slope dP by dQ of the demand curve, although the concepts of slope and elasticity are quite different. In particular, with a linear demand curve, elasticity changes as we move along the demand curve, as both P and Q change, even though the slope of the curve is constant. For relatively high values of P and low values of Q, elasticity is greater than unity. For relatively high values of Q and low values of P, elasticity is less than unity, while it is exactly equal to 1 at the midpoint when P is equal to Q. We know that for most goods, a fall in price will cause an expansion in demand. But if that expansion in demand were proportionately greater than the fall in price, we would say that the quantity demanded is very responsive to a price change. Thus, demand is said to be relatively elastic. With elastic demand, a price cut leads to an increase in the sales revenue. In the opposite situation, in the case of a relatively inelastic demand, there has been a less than proportionate change in quantity demanded, a weak response to a price change. With inelastic demand, a price reduction leads to a lower sales revenue. When the proportionate change in quantity demanded is the same as the proportionate change in price, demand is said to be unitary elastic. In this case, total sales revenue is same even after a price reduction. As we have seen above, elasticity depends upon the slope of the demand curve. This can be demonstrated in the following cases. When we have a perfectly vertical demand curve, quantity demanded remains exactly the same, regardless of the price. The type of demand curve is called perfectly inelastic demand curve. A perfectly horizontal demand curve indicates that consumers are willing to consume any quantity demanded, but only at a certain price. In this case, owing to the slope of the curve, the value of elasticity is infinitely large, and this type of a demand curve is called perfectly elastic demand curve. There are certain non-linear demand curves along which elasticity is constant. One example of this is a demand curve that is a rectangular hyperbola, which has unit elasticity all along the curve, as shown in figure 4. Such curves are called constant elasticity demand curves. Factors affecting price elasticity of demand. We now discuss some of the major factors that make the demand for some products more elastic than the demand for other products. The first is the availability of substitutes. This is one of the most important factors that influences the price elasticity of demand. The better the substitutes available for the product, the more elastic would be the demand. For such goods, when there is an increase in price, the consumers reduce the consumption substantially as close substitutes are available. Hence, availability of substitutes make the demand more responsive to a price change. On the other hand, if no close substitutes are available and if the consumption of good is essential, then the demand may not respond much to a price change. For example, suppose there is an airline G which captures a significant share of the market, but has good substitutes in the form of other airlines available. Then, if the producer increases the price of the air tickets by 20%, consumers may respond by shifting to some other airline service which has a lower price. But if this airline plies along a route on which alternate flights are not available, then people may buy tickets from G anyways, in which case the demand would be relatively inelastic. Therefore, if close substitutes are available, demand for a good will be relatively more elastic. On the other hand, with relatively poor or few substitutes available, demand would be relatively inelastic. Other factors: all other things remaining constant, price elasticity is likely to be directly related to the share of expenditure on the goods in the consumer's budget. This implies that the demand for car is probably more elastic than the demand for milk, because the expenditure on a car tends to constitute a large proportion of the budget for a typical consumer than everyday consumables like milk. The nature of the good, whether it is an essential good or a luxury item, is also likely to affect the response of demand to a price change. In case of the former, the essential good, demand is likely to be relatively inelastic compared to the latter. The period of time at which elasticity is measured is also likely to affect its value. For example, if the price of milk increases by 20%, immediately the demand for milk will not be affected much due to several reasons. For example, many people may not know about the price rise. Those who know about the price rise may not be able to adjust the quantity demanded immediately, and so on. Therefore, if elasticity is measured immediately after the price change, demand may appear to be relatively inelastic. However, if measured sometime after the price change, the situation may differ. As consumers look for ways to reduce consumption of milk or look for substitutes with similar nutritional value, example eggs, cheese, etc., the value of elasticity may be higher and demand might appear to be price elastic. Calculating the price elasticity of demand. The mathematical formula for calculating price elasticity of demand is given by the following equation. Change in Q by Q multiplied by 100 divided by change in price divided by price and multiplied by 100. That is equal to delta Q by delta P multiplied by P by Q, which is equal to the inverse of the slope of the demand curve multiplied by the price to the quantity ratio, where delta is the change in demand, which is Q1 minus Q0, and Q0 is the original demand, and delta P is the change in price, which is P1 minus P0, and P0 is the original price. Let's understand this with the help of an illustration. If the price of X goes up from rupees 20 to 25 and the demand for X falls down from 3000 to 2700 units, then the elasticity may be computed as follows. The change in quantity is minus 300, the change in price is 5, original price is 20 and the original quantity is 3000. Plugging these values in this formula, we get elasticity as minus 0.4. This is also known as the point elasticity of demand. It is the computation of elasticity at a point on the demand curve. There is another method to calculate elasticity between two different points on an interval of the demand curve, which is also known as the interval elasticity or arc elasticity. This measures the price elasticity of demand between the 2 points on the demand curve. To measure elasticity over an interval, the above formula gets modified slightly. Instead of taking P by Q, we now take average P divided by average Q. The formula becomes elasticity is now change in Q by change in P multiplied by the average price divided by the average quantity. You should calculate arc elasticity using the information on price and quantity given in the above example. As to how we can measure elasticity along a demand curve. First, for a linear demand curve. To see why, we look at the mathematical formula for elasticity. We know in a linear demand curve the slope, that is delta P by delta Q, is constant. Moving along a linear demand curve doesn't change slope, but the second component of the elasticity formula, that is P by Q, varies as we move from one point to another, thereby leading to a change in the total value of elasticity. If we move down the curve, the ratio P by Q falls, which reduces the absolute value of elasticity. Similarly, if we move up the curve, P by Q increases, leading to an increase in the absolute value of the elasticity. So, there is a direct relation between price and elasticity. Second, the nonlinear demand curve. In a nonlinear demand curve, both the slope as well as the ratio change as we move from one point to another. However, there is no relation between price and elasticity as such. For the constant elasticity demand curves, there are certain nonlinear demand curves along which elasticity remains constant. For example, for the demand curve given by Q is equal to P raised to the power minus alpha, the elasticity alpha is constant at all points along the demand curve. One example of this is a demand curve that is a rectangular hyperbola, which has unit elasticity along the curve. In general, the value of alpha may be greater than unity in the case of elastic demand or less than 1. Such curves are called constant elasticity demand curves. Elasticity at the intersection of two demand curves. Consider the case when there are two intersecting demand curves for good X, D1 and D2, representing the demand for two different consumers 1 and 2, where D1 is steeper than D2. And in this case, what can we say about the price elasticity at the intersection of two demand curves? We can see this in the following graph. If the two demand curves D1 and D2 are intersecting at point T, what is the elasticity for both the demand curves? Are they the same or different? If the two demand curves intersect each other, then the curve which is relatively flatter will have a higher price elasticity of demand. This is because the flatter demand curve, greater is the percentage change in demand due to a percentage change in price. Note, slope of the demand curve is given by dP by dx. According to the elasticity formula given above, for the demand curve D1, price elasticity is slope of D1 multiplied by Px1 divided by x1, and for the demand curve D2, price elasticity is slope of D2 multiplied by Px1 divided by x1. Since slope of D1 is less than slope of D2, therefore the elasticity of demand curve 1 is less than elasticity of 2. Hence, the flatter curve has a greater elasticity of demand at the point of intersection. Now let's compare the elasticity of two parallel demand curves. Consider a demand curve D1. Suppose there is a parallel outward shift in the demand curve to D2. The reason for the outward shift may be an increase in income of the consumer. An advertisement campaign for good X may have led to a shift in preferences of the consumer towards good X. Suppose at the price Px1, there is a change in demand from x1 to x2 due to a shift in demand from D1 to D2. Then, what can we say about the elasticities of demand at point R and R prime? At point R, price elasticity is given by slope of D1 multiplied by Px1 divided by x1. At point r prime, the price elasticity is given by slope of d2 multiplied by p x1 divided by x2. Since we are considering a parallel shift, slope of d1 is equal to slope of d2, while x1 is less than x2. So, elasticity of 1 is greater than elasticity of 2. Hence, price elasticity is not the same at a given price for two parallel demand curves. Importance of elasticity: total revenue and price elasticity of demand. Price elasticity of demand is a useful concept. It helps us to answer the question, how will revenue from sale of goods change as we change the price? Total revenue, which is defined as the total amount the producers earn from the sale of good, that is TR is P into Q, gets affected by change in price and quantity. Note that change in TR is equal to marginal revenue, which is equal to the output effect plus the price effect. Given the inverse relation between price and quantity demanded, changes in P and Q essentially move in the opposite direction. The relative strengths of the two depends on the elasticity of demand for the product and determines the overall impact of a price change on TR. We will see how this happens. When a producer increases the price, this would increase the total revenue if the quantity sold remains the same. In case the prices are lowered, then TR would fall if quantity sold remains the same. This effect of a price change on TR is called the price effect. However, when price changes, the quantity sold does not remain constant. It moves in the opposite direction of price and affects TR in the process. The impact of the change in quantity sold on TR for a given price level is called quantity effect. When there is a change in price, both the price and quantity effects are at work and change in TR depends on which effect is stronger. If a producer increases the price of his product, this would reduce quantity sold, and either of the following cases will be observed depending on the demand elasticity for the product. Case 1, when the demand is unitary elastic. Recall from our discussion above, in this case dQ by Q is equal to dP by P. That is, the magnitude of the price effect is equal to the magnitude of the quantity effect. So, both effects exactly offset each other as they move in the opposite direction and are equal in magnitude. In this case, as price increases, total revenue remains the same. Case 2, when demand is elastic. Recall from our discussion above, in this case dQ by Q is greater than dP by P. That is, the magnitude of the price effect is now less than the magnitude of the quantity effect. This pulls TR in the direction of the change in quantity as the quantity effect is dominant. In this case, as price increases, quantity decreases and total revenue decreases. In the opposite case, when price decreases, quantity demanded and TR would increase. Now, let us look at the case 3 when demand is inelastic. Again, recall from our discussion above that in this case dQ by Q will be less than dP by P. That is, the magnitude of the price effect is now larger than the magnitude of the quantity effect. This pulls total revenue in the direction of the change in price as the price effect is now dominant. In this case, as price increases, quantity decreases but total revenue increases. In the opposite case, when price decreases, quantity demanded would increase but TR would decrease. Now, let us look at demand, marginal revenue, price elasticity and their relation. Besides total revenue, an equally important concept for pricing and output decisions is the marginal revenue. It is defined as a change in total revenue due to a change in the quantity sold. MR is the slope of TR. MR is related to price elasticity because MR, like price elasticity, involves changes in TR caused by movements along a demand curve. The concept of marginal revenue will be dealt with in more detail when we look at the chapter on firm behavior that deals with firms' decision to produce and sell goods. However, There is a relation between MR and price elasticity that needs to be noted at this juncture. MR is equal to the price for the first unit, but for every unit thereafter it is less than the price because price has to be lowered in order to sell an additional unit. So, the MR curve begins at the same point on the vertical axis as the demand curve, but thereafter it lies below the demand curve. This can be seen via the example in table 2 above. For the first unit in the table, P is equal to MR is equal to 4 rupees. Now, as the price is lowered to rupees 350, it is reduced for the first as well as second unit. So, MR for the second unit, that is the price minus reduction in price to sell this second unit, that is 3.50 minus 0.5 is rupees 3. Hence, MR is rupees 3 in this case, or the additional revenue earned by selling an extra unit is less than the price. You should verify the relation between price and MR for the third, fourth and fifth units for yourself based on this data. Note that MR falls as price is further lowered and eventually reaches 0 and becomes negative thereafter if price is further reduced. This relation is depicted graphically in figure 5. When the demand curve is linear, marginal revenue is also linear and lies halfway between the demand and vertical axis. This implies that MR is twice as steep as the demand curve as shown below. Example, if the demand curve is Qx is equal to A minus BPX, then total revenue is price into quantity and we get the expression of APX minus BPX square. This implies that marginal revenue, which is change in TR by change in quantity, is A minus 2BPX. In figure 7, the graphical relation of the elasticity and the marginal revenue is depicted for a linear demand curve. Further, we will use the relation between elasticity and the change in TR discussed above and use these to study the relation between elasticity and MR. When demand is elastic, that is E is greater than 1, MR is greater than 0 because TR rises as Q rises and P falls. When demand is inelastic, epsilon is less than 1, marginal revenue is less than 0 because TR falls as Q rises and P falls. And when demand is unitary elastic, that is equal to 1, MR is 0 because total revenue does not change as Q rises and P falls. Hence, for the entire range where marginal revenue is positive and the good is relatively elastic, TR is increasing with Q. This is depicted in the lower panel of figure 7. After that, at the point MR is equal to 0, where elasticity is 1, TR is maximum. After this point, MR becomes negative and elasticity is less than 1 and TR declines as Q increases and price falls. This relation has been summarized in the table 3. Now let's look at the other important demand elasticities, such as the income elasticity of demand. It is important to measure the sensitivity of demand to changes in consumers' income. In other words, we need to know how a consumer's demand for good X changes when there is a change in his or her income. This is measured by the income elasticity of demand. Income elasticity is defined as the percentage change in quantity demanded for the good QX in response to a percentage change in the consumer's income M. Mathematically, elasticity of income is equal to the change in quantity of X by QX, which is divided by change in income divided by the original income. Note that the sign of income elasticity of demand depends on the sign of change in QX by change in M, as M by QX is always positive. Also note the following important classification of goods based on the concept of income elasticity of demand. First, for a normal good, as income increases, quantity demanded increases, so that the sign of delta QX by delta M is positive. Thus, if the good is normal, EM is always positive. Further, for normal goods where EM is greater than 0, if the quantity demanded responds more than proportionately to change in income, then EM is greater than 1, which implies that the demand for good is income elastic. On the other hand, if the change in quantity demanded responds less than proportionately to change in income, then income elasticity is between 0 and 1, implying that the demand for good is income inelastic. For an inferior good, as income increases, quantity demanded decreases. In this case, the sign of delta Qx by delta M is negative. Thus, if the good is inferior, EM is always negative. The relationship between income and quantity demanded is given by the Engel's curve. It is depicted in the following diagram. The Engel curve essentially shows the amount of the good that would be demanded by a consumer at different levels of income. Next, we come to the cross price elasticity of demand. A change in the price of related goods also affects the quantity demanded for a good X. Either these related goods are substitutes or could be complements of good X. The impact of a change in the price of R on quantity demanded of good X is given by the cross price elasticity of demand. The cross elasticity of demand measures the responsiveness of quantity demanded of one product to the changes in the price of another product. For example, we can use this concept to measure the extent of change in quantity demanded of Coca-Cola to changes in the price of Pepsi. Cross elasticity of demand indicates how close a substitute or a complement is to the commodity. For example, as the price of Pepsi increases by a certain percentage, consumers may increase the purchase of Coke by a proportionately higher percentage. In such a case, the cross price elasticity of demand for Pepsi would be termed elastic when measured with respect to the price of Coke. The mathematical formula for cross price elasticity of demand is change in quantity of X by X divided by change in price of related commodities to the price of related commodity. Note, PR is the price of related good here. Clearly, the sign of EXR depends on the sign of change in QX by change in PR, which could be negative or positive. If the goods X and R are substitutes, then change in QX divided by change in PR is greater than 0. That is, more of X is bought with a rise in price of R. This implies that EXR is positive. If the two goods are perfect substitutes, then the cross price elasticity of demand would tend to positive infinity. Example, if we consider Pepsi as a perfect substitute for Coke, then EXR would be positive infinity. If the goods X and R are complements, then change in QX by change in PR is less than 0. That is, less of X is bought when there is a rise in the price of R. This implies that EXR is less than 0. Example, pen and refills are complementary good. If the price of refills rise, then the demand for pens may fall. Note, for independent or unrelated goods, EXR would be close to 0. Now let's summarize. Elasticity of demand for a good measures the degree of responsiveness of quantity demanded to changes in the determinants of demand, be it own price, income, as well as prices of other goods. The price elasticity of demand measures the percentage change in quantity demanded of a good Q due to a 1% increase in its own price P. Factors such as availability of substitutes, proportion of income spent on the good, time period for adjustment, etc. affect the price elasticity of demand for the good. There are two methods for calculating price elasticity, point elasticity and arc elasticity. In general, price elasticity varies along a demand curve. However, there are exceptions, which are known as constant elasticity demand functions, along which elasticity of demand remains constant. Example, when the demand curve is a rectangular hyperbola, elasticity is unity throughout. There is a relation between TR and price elasticity. When good is inelastic, then TR increases, as price of good increases. When demand is elastic, TR decreases as price of good increases. And when demand is unitary elastic, TR remains unchanged with a change in the price of the good. There is a relation between price elasticity and MR as well. When demand is elastic, MR is positive. When demand is unitary elastic, MR is 0. When demand is inelastic, MR is less than 0. Income elasticity measures the percentage change in quantity demanded in response to a percentage change in income. Income elasticity is positive for normal goods and negative for inferior goods. The cross elasticity of demand measures the responsiveness of a quantity demanded to changes in the price of the related goods. Elasticity here would be positive for substitutes and negative for complements.